June 4th, 1942. Forward Airfield, Midway Atoll, Pacific Theater. The tactical briefing officer marked the map with methodical precision. Japanese Zero fighters confirmed inbound from Carrier Task Force. Estimated arrival 0900 hours. Captain James Buck Morrison, one of the first American fighter pilots to survive prolonged combat against Japan's legendary Mitsubishi Zero, studied the intercept orders with grim determination. 12 Wildcats against an unknown number of Zeros, aircraft that had dominated Pacific skies since the war began. What none of them knew was that these fabric-covered fighter planes were about to prove that aggressive American tactics could challenge the Zero's supposed invincibility. The Zero owned the skies over the Pacific. Since the Japanese attack on Pearl Harbor in December 1941, Zero fighters had torn through American formations with near impunity. Pilots called them the Zeke, and they had become the symbol of Japanese air superiority in the Southwest Pacific. American forces had learned through bitter experience that the Zero could turn inside any American fighter, climb faster at altitude, and outmaneuver conventional pursuit tactics. The Zero's superiority in aerial combat had been demonstrated catastrophically at the Philippines in January, where Japanese fighters shot down 47 American aircraft in 3 weeks. Their 19mm cannon could penetrate American armor plating. Their pilots had trained for years in acrobatic dogfighting techniques. Their aircraft possessed superior maneuverability that seemed to defy physics. Vice Admiral Isoroku Yamamoto's strategy was straightforward. Control the air, control the seas, control the supply lines, maintain the offensive. Americans might possess industrial capacity, but the Zero pilot represented warrior culture, perfected through generations of military tradition. Without air superiority, the Japanese Empire would expand unopposed across Asia and the Pacific. The P-40 Wildcat represented American resilience under pressure. Fighting Plane Squadron 12 had arrived at Midway, with the first aircraft in February 1942. Each Grumman-built Wildcat weighed 6,300 pounds empty. Wingspan 37 feet, length 28 feet, service ceiling 31,000 feet. Slow by Japanese standards, but sturdy beyond measure. Captain James Buck Morrison examined his aircraft's armament in the harsh tropical sunlight. 650 caliber machine guns mounted in wings, 800 rounds per gun, weapons that required precise marksmanship. 4.50 caliber rockets mounted under the fuselage, experimental munitions that suffered from inconsistent reliability. The Wildcat's primary advantage was durability. The fuselage constructed from welded steel tubing, engine surrounded by 9mm armor plate, self-sealing fuel tanks that could absorb 20mm cannon rounds. The aircraft could take punishment that would destroy a Zero. Pratt & Whitney 1,800 horsepower engines, maximum speed 318 miles per hour at 15,000 feet, inferior to the Zero's 332 miles per hour. But the Wildcat's engine could withstand 12G loading, where Zero airframes began structural failure beyond 9G. Master Sergeant Eddie Chen had spent 6 months learning every mechanical subtlety the Pratt & Whitney engine possessed. An engineer from San Francisco, who had worked on assembly lines before enlisting in the Army Air Forces, Chen could diagnose engine problems by vibration patterns alone in complete darkness. This engine is forgiving, Chen explained to new pilots. Wrong fuel mixture and you lose 150 horsepower. Push it into decompression and you throw a rod, but treat it right, and it'll withstand maneuvers that would kill a Zero pilot. Chen had developed maintenance procedures, optimized for tropical conditions. He created a pre-combat checklist that included precise fuel mixture settings, engine timing adjustments for maximum power delivery at altitude, and procedures for detecting metal particles in oil that indicated internal damage. His innovations kept aircraft operational when manufacturer specifications predicted failure after intense combat stress. Lieutenant Commander Hideki Shoji stood in the cockpit of his Mitsubishi Zero, leading 4 fighter sections toward Midway Atoll at 400 kilometers per hour. 8 years in the Imperial Navy had taught him to read the sky. Every cloud formation might hide enemy fighters. Every glint of light could mark hostile aircraft. Today's mission: escort the bombing formations attacking the American airfield. The bombers would reduce Midway's defenses, while fighters maintained air superiority. The Zero's primary vulnerability was its lack of armor protection. At 30,000 feet altitude, the airframe began stress fractures if subjected to sustained turning combat. The lightweight construction that provided superior maneuverability also meant that sustained geo-loading damaged structural integrity. Engine damage at altitude meant rapid descent with few options for recovery. Against disciplined American pilots employing formation tactics, individual Zero pilot skill mattered less than the previous 6 months of aerial combat suggested. June 4, 1942, 0830 hours. 12 Wildcats orbited above Midway at 15,000 feet. Engines throttled to economical RPM to preserve fuel and reduce noise. No radio communication, except essential tactical updates. Only hand signals and wing rocking for maneuver coordination. Captain Buck Morrison, in the lead Wildcat, spotted the contrails first. 4 fighter sections of Zeros in stepped formation, maintaining altitude advantage. The standard American defensive doctrine called for climbing to altitude and attempting to achieve position advantage. But Morrison chose unconventional tactics, developed through analysis of previous combat reports. All aircraft would attack the lowest Zero section, concentrate firepower on individual targets, then disengage before Japanese numerical superiority proved decisive. The Wildcats dove at full throttle, engines screaming in the thin air. Morrison pushed the yoke forward, increasing airspeed rapidly toward 450 miles per hour. At 10,000 feet, the Zeros detected the Americans and turned hard into the approach. The fight was on. The first burst of 50 caliber machine gun fire ripped through the Zero's right wing, explosive rounds igniting fuel vapor. The Japanese pilot yanked the stick back, rolling inverted to gain separation. Morrison stayed locked onto the target, ignoring every textbook rule about dogfighting a Zero. He pushed the Wildcat into a diving turn that American pilot training explicitly forbade, pulling nearly 12 gi, loading that threatened structural failure. The Zero's airframe, designed for sustained 9G maneuvers, began shedding paint and panel sections under the extreme stress. Morrison's reinforced armor plate protected him from return fire as the Zero's 19mm cannon rounds sparked harmlessly off his engine cowling. The Zero rolled upright, attempting to reverse the engagement, but Morrison's Wildcat, dumpy and powerful, completed the turn faster than theoretically possible and fired another burst. 20 rounds struck the Zero's fuselage, destroying the fuel injection system and rupturing the oil cooler. Black smoke poured from the Japanese aircraft as the pilot pulled up steeply, attempting to reach altitude where the Zero's superior climb rate would provide escape. Morrison throttled to full power, his inferior climb rate barely sufficient to maintain pursuit. At 22,000 feet, the Zero's engine sputtered and failed from damaged oil circulation. The Japanese pilot, realizing he was finished, pulled the canopy open and prepared to bail out. Morrison broke off pursuit, searching for the next target. 3 other Zeros fell to coordinated Wildcat attacks during the first engagement. The American pilots, acting with aggressive determination and ignoring conventional tactical wisdom, claimed 4 confirmed kills before the remaining Japanese fighters broke contact and climbed toward altitude. The June 4th battle convinced Japanese commanders that American fighter tactics were evolving beyond previous expectations. By July 1942, additional Wildcat squadrons arrived with new tactical doctrines developed through hard experience. Intelligence revealed Japanese patrol patterns, regular combat air patrol flights, 4 aircraft sections, rotating continuously. Tactics predictable. Altitude advantage pursued religiously based on Zero superiority at height. Captain Morrison developed new fighter tactics based on early encounters. American pilots would refuse engagement at altitude disadvantage. Instead, they would lure Japanese fighters into turning combat where Wildcat durability and superior G-loading tolerance would prove decisive. When Zeros achieved position advantage, Wildcats would execute climbing spirals that Japanese pilots could follow only by exceeding airframe limitations. Following the surface action at Coral Sea, where Japanese carriers achieved tactical advantage, fighter aircraft became the decisive element in carrier operations. While they could not match the Zero's maneuverability in sustained turns, American tactics leveraging superior durability forced changes in Japanese air combat doctrine. Wildcats patrolled the approaches to American carriers, attacking Zero formations when possible. Though individual pilots occasionally encountered superior Japanese aviators, the collective tactics forced Japanese commanders to abandon altitude advantage strategies and engage Wildcats in low-altitude turning combat, where American aircraft proved surprisingly effective. By August 1942, larger Zero versus Wildcat engagements demonstrated the effectiveness of Morrison's tactical innovations. Japanese pilots, trained to exploit maneuverability advantage at altitude, struggled against American pilots who refused to conform to conventional fighter tactics. 23 confirmed Zeros fell to Wildcat pilots, employing aggressive turning combat and sustained G-loading techniques. The psychological impact was significant. Japanese combat reports noted, American fighter pilots now aggressively pursue Zero aircraft into regimes where we believed we possessed overwhelming superiority. Pilots report aircraft structural stress exceeding design limits. Many airframes require extensive repair after engagements with American Wildcats. Captain Morrison achieved 15 confirmed kills, making him one of the most successful American fighter pilots against the Zero. His innovations in tactical doctrine influenced fighter operations throughout the Pacific. The Wildcat, initially viewed as inferior to the Zero, demonstrated that disciplined American pilots could achieve success through aggressive tactics and superior aircraft durability. Admiral Yamamoto, personally directing air operations, recognized the shifting calculus. Japanese pilot training emphasized individual maneuvering skill. American pilot training increasingly emphasized tactical formation discipline and aircraft maximum performance exploitation. Yamamoto noted, the Wildcat pilots fly with determination that contradicts their aircraft's supposed limitations. They maneuver beyond what physics should permit, and their airframes withstand punishment that destroys Zero structures. By September 1942, the tactical balance had fundamentally shifted. American pilots no longer feared the Zero's maneuverability advantage. Instead, they respected it, while exploiting the aircraft's structural limitations. The introduction of the F4F Wildcat's successor, the F6F Hellcat, in mid-1943 accelerated American air superiority. The Hellcat matched the Zero's maneuverability, while providing superior armor protection and diving speed. The Hellcat pilots, trained by veterans like Morrison, demonstrated that integrated American air tactics could achieve overwhelming numerical advantage over individual Japanese pilot skill. Production statistics revealed the strategic equation. The United States built 9,446 Wildcats during World War II. Each fighter required 4 months to build and cost $60,000. Training programs at advanced fighter schools produced 3,500 fighter pilots annually by 1943. Each pilot received 12 weeks of intensive combat training before deployment. By mid-1943, new radar-equipped fighters allowed detection at 50 miles. The improved ammunition, introduced in late 1943, increased reliability significantly. These improvements transformed American fighter tactics into more lethal combination, though their primary achievement remained proving that aggressive pilots could challenge Japanese air superiority. The Imperial Navy attempted various countermeasures with limited success. Experienced Zero pilot veterans mentored new pilots in turning combat techniques, but American pilot rotation policies meant experienced American pilots remained in theater while Japanese experienced pilots were rotated home to train new generations. Float planes provided early warning of American fighter patrols, but this also revealed Japanese aircraft positions. The shift to defensive fighter tactics proved insufficient. Japanese industrial capacity could replace aircraft losses, but training replacement pilots to the skill levels of experienced aviators required years. The development of improved Zero variants represented Japanese adaptation to American fighter threats. The A0M30, introduced in early 1944, featured additional armor and heavier armament, but these modifications reduced maneuverability advantage and increased aircraft weight. The Zero's technological advantage, dominant in 1942, became historical curiosity by 1944 as American industrial production and tactical innovation overwhelmed initial Japanese superiority. Captain Morrison survived 237 combat missions, shot down 6 times, surviving 1 bailout over enemy territory by swimming 12 hours to American destroyer escort. His leadership in reshaping American fighter tactics influenced Pacific air warfare strategy for the remainder of the conflict. The Wildcat campaign revolutionized understanding of air combat and asymmetric aerial operations. While Wildcats were individually inferior to Zeros in maneuverability, aggressive American tactics and superior aircraft durability proved decisive. The progression from early defensive tactics to aggressive pursuit formations represented tactical victory through superior pilot training and disciplined formation tactics. Modern fighter doctrine evolved from lessons learned in Pacific aerial combat. The emphasis remained on situational awareness, tactical discipline, and exploiting aircraft performance limits within structural capability. In the skies above the Pacific, fabric-covered American fighters had proven that aggressive tactics could challenge supposed invincibility. Wildcats alone could not achieve air superiority, but combined with superior pilot training, disciplined formations, and willingness to exploit aircraft durability limits, they contributed to cumulative advantage that proved decisive. The Japanese Navy entered the war confident in pilot training superiority. They had not anticipated that American forces would embrace unconventional tactics, aggressive maneuvering, and technological adaptation that would gradually overwhelm initial Japanese advantages. The final accounting was strategically significant, despite initial tactical disadvantage. Hundreds of confirmed Zero kills achieved by Wildcat pilots, thousands of tons of supplies lost, when Japanese air superiority failed to protect transport formations. The cumulative effect contributed to American victory in the Pacific. In the skies where so many aircraft fell, the legacy of Morrison and his aggressive Wildcat pilots endured as testament to the young men who fought in fabric-covered fighters against supposedly superior Japanese aircraft, proving that courage and tactical innovation could influence strategic outcomes, even when initial combat analysis suggested overwhelming odds. The Wildcat pilots had demonstrated that future air warfare would require tactical adaptation, aggressive pilot training, and recognition that even inferior aircraft could achieve victories when employed by determined pilots willing to challenge conventional wisdom.